Hey guys, it's us.
Atoms make up
Everything. Actually, no.
quarks make
Everything. Quantum mechanics is like the probability simulator on your TI-84 Plus. Let's pick some marbles. Hey TI-84 Plus, what are the chances of me picking marble C? It's 12.
See, that's just like quantum mechanics. In quantum mechanics, objects exist and behave in a haze of probability. It tells you the odds of something happening, specifically the behavior of the stuff that makes up
atoms. Newton said, introducing corpuscles.
But everyone said, no, that's wrong, they're particles.
Some guy named Christian Huygens said light is made out of waves.
But everyone said, no, that's wrong, they're not.
Everyone was like, so is like light made of atoms or particles?
Trick question, they're not.
Suddenly light is neither. And now it's both.
How is it possible?
I don't know, but let's put light through two different slits.
How does it work?
Waves and stuff.
Hey, what if we destroy some waves?
How would we do that?
Through destructive interference.
What if I did the opposite?
That's constructive interference.
Okay, but how does that work?
A trough and a peak are at the same position. They cancel each other out.
Wait, I'm lost.
That's quantum mechanics. So let's start with
Quantum
properties. Quantized properties are properties such as position, speed, and color that can sometimes only occur in set amounts. So there's this guy, right? Max Planck.
Max Planck was the originator of the quantum theory. He's so quirky and different.
In the 1900s, Planck was working on a thermodynamic problem given by his teacher. His teacher was like, hey my guy, so please explain the colors of hot glowing matter. Thanks.
Theoretically, when the objects absorb heat, they were supposed to radiate all frequencies of light equally. But life's like, psych! Nope, that's not how it works. So Max Planck was like, alright, Chief, let me figure this out for ya.
He decided to open up his mind, put down his Uno reverse card, and switch up the old ways of thinking, which was that energy is radiated in a continuous wave. Max discovered that energy does not flow evenly, but instead radiated every minute and is released in discrete packets, or quantum.
My lord!
This explains why only certain frequencies of light are emitted when the objects are heated.
He found out that the energy of each quantum is equal to the frequency of the radiation multiplied by a universal constant, or Planck's constant. This. What a smart boy!
What a smart boy. With Planck's work, he helped some people who were struggling academically, like this guy, to describe the particle properties of light.
Have you ever lost sleep over your fascination of whether or not light is a wave or a particle?
No.
Our pal, Sir Isaac Newton, local skinny legend, determined that light was a group of particles. If I could have light go through two tiny holes, then the light itself continues through those holes. Kind of like a wave, but also like a particle.
Local dynamics, Francesco Maria Grim Reaper and Vanessa Hudgens saw that the diffraction of light looks the same way that the waves diffract through the things like slits.
Augustine Jean Fresno saw that lights had a short wavelength and found a way to discover interference in light. Thomas Young piggybacked on this theory, discovering that light is a transverse wave. Transverse. Wow.
Our new local skinny legend, James Clerk Maxwell, thought, hey, I think I discovered something called an electromagnetic wave. It's just a name.
Out of Maxwell's thoughts, he magically discovered that light is an electromagnetic wave.
He even proved this with equations.
Excuse me, did you forget that Isaac Newton existed? Said Albert Einstein, who looked at his light as a particle. Einstein put his foot down and opened his mouth. He screamed at the other scientists, saying, light is actually a particle that has a flow of a wave, so I guess we can call it a, photon.
Photon. Yeah, I didn't know how to segue this, but, waves of matter.
So we have another dude, Louis de Broglie.
De Broglie was like, hey man, so if light is supposed to be like a wave, then should particles like electrons, protons, and neutrons be like waves too?
Thus started the concept of wave particle duality, where every quantum being can be described as a particle or a wave. Wow! Get a quantum entity that can do both!
Broccoli found out about particle waves. Yeah. The probability of finding a particle at a certain location depends on the wave associated with the particle. So the larger the amplitude of the wave, the larger the probability that the electron will be found there. Go, go, particles!
He then came up with this equation.
Then these two other scientists were like, hey, so Broccoli's ideas seem pretty cool, right? Yeah. Yeah, so let's use it to find out how electrons go around atoms. Yeah.
They found out that electrons will diffract and interfere like waves. So matter and light are composed of particles that have wave-like properties.
Pip pip cheerio!
That's right!
Last thing, gamers.
You can never know where an electron is or where it's going.
There's uncertainty in quantum physics.
This guy in the description below says so. Chip chip.
Okay. You've quantum mechanics. Yeah.
Cheerio!